All right, guys. Uh, I heard the complaints. I'm kind of looking at the screen right now. Hopefully, my voice is better. Couple of things. I don't know what happened to the closed caption. That's why I use YouTube. YouTube actually is really good about closed caption. Uh, and I'm not sure why some of you were able to get closed caption and others were not. The other thing is, I know this is kind of last minute and we're just trying to make things work with Miss Penn gone. I'm using this new little tiny camera because my old iPad was destroyed and we can't use it anymore. I'm not sure if this camera has the greatest of quality. So I brought you guys in closer. I won't be able to do as much on the board, but we'll make it work. So today we're going to tackle 351, 22 to 33, and we're going to do log inequalities here. So here's the deal. So we don't solve them any differently, okay? So we don't solve these things any differently. So we're going to I have two of them here. Don't worry about this. This is the next example I'm going to show you. I have two of them here, but the thing I want to draw your attention to is which way the arrows are pointing, which is a very, very big deal, okay? So we want to make sure that we understand what happens when these are there. So we solve it just like we did the other day. I got some different colors here. So we're going to switch our X and Y, which was what you guys practiced on Monday. And then I'm going to get something like that, right? And then I am going to get, let me think here. Hold on. This seems to be backwards. I think the book's got something funky in there. Now, when we switch X and Y, we switch our inequality. That's one of the things to do. But the easier way to tackle this thing is to actually just say, okay, X is going to stay here, and then I am going to write this as 3 to the 4th. Okay? So that's my inequality. Okay? If you switch it normally, like we did earlier, let me write this off to the side. If you switch it, hopefully you guys can't see that. If you switch this the way that we normally do it, you get 3 to the 4th, and we get X over here. But since I'm switching X and Y, the direction of this changes. These two are the same thing right here. If we flip this around, it makes this direction. So it's easier to just kind of keep the X over here and make this 3 to the 4th power. Okay? Now from there, we get X is greater than 81. And so you're going to see answers that look like this. X such that X is greater than 81. That's all that means, guys. Don't panic when you see answers like this. Like, what are the two X for? Relax. Don't panic. X such that X has to be greater than 81. That's all it means. Which works because if we graph the logarithm, remember, if we graph the logarithm, it can't be to the left of 0, so it's got to be all positive. And these are all positive. So domain's going to come into play here. Now, this one, let's tackle it the way we just tackled it right here. We're going to keep the X over here, switch these two, and we get 2 to the 4th power. So we're all set up there. Now we get X is less than 16. Cool. Easy way to do it. Oh, the other thing, guys, is as I'm doing these for you guys, if there is a certain color you cannot see very well when you guys watch them, just let one of the kids know that knows me or can send me a message. I'll change whatever you need to change. So, like, I know some of you couldn't see the little points I was writing. I don't know what it looks like on your end. I just know what I can see on my computer. So I know you can see red. I know not to use green from other classes. So just let me know those things. So now we've got this piece right here, and we know one thing. We know that X has to be less than 16. But if I look at the graph of a logarithm, we know that, excuse me, that this answer says everything's got to be less than 16. But by nature, in other words, the rules of logarithm, this log base 2 of X cannot go to the negative 0. So all of this, I'm going to start coughing here. All of this is off limits. You can't go over there. So our answer looks a little different. If we write it the way you're going to see it in your answers, x such that 0 starts the domain, which is less than any value of x, which is less than 16. Okay? So what we're saying here, look, what we're saying is this area right here from 0, x can be anything right here. That may be a little small for you guys to see. X can be anything in between here. X such that x is between 0 and 16. That's how you're going to see the answers, okay, when we're dealing with inequalities. All right, so let's tackle that. I ditched the questions at the beginning. If that confused you guys, it was just me trying to get started because this is a whole different extra lecture for me that I'm doing for you guys. So trying to keep you guys going. So some of the stuff, if you have questions, don't be scared. The calculus kids don't bite. They're nice. They work a lot and they work really hard, but they're good. They won't make fun of you. They'll actually really like the fact that you come over and they can do some of this stuff. They'll help you. I'll help you. Whatever. Don't be afraid. Okay, so now we're going to tackle some of the bigger ones. So log base 4 of x plus 3, which is greater than log base 4 of 2x plus 1. Okay, let me double check you guys can see it. Okay, so far so good. Sorry about the glares, guys. I'm just, like I said, I'm trying to get this camera thing to work right. So that's our bad boy right there. So in the last video, or yesterday on Wednesday, a 1-to-1 rule. So we know for a 1-to-1 rule, excuse me, that's going to cancel, and that's going to cancel. So I'm going to get x plus 3, 2x plus 1. Now, we got a problem here, though, because we know a couple of things. We know that this cannot be less than 0. Okay? It can't be less than 0, so we know that this middle has to be greater than 0. And this has to be greater than, which actually it cannot be 0. Greater than 0. Okay? You guys okay with that? So we know that this middle piece, when we plug a number in here, the answer cannot be less than 0, so it has to be greater than 0. So let's look at that. Let me grab another color. If I create an equation that says x plus 3 has to be greater than 0, this whole thing has to be greater than 0, because when I draw my graph's over here somewhere, always. It's got to be greater than 0. That means that x greater than -3 will be good. So that's my domain for that one. Okay? That's my domain for this one. Let's do the same thing here. 2x plus 1. Hopefully you guys can see that. It's 2x plus 1. I need to write that bigger. 2x plus 1 is greater than 0. That means I move this over. -1, 2x. X is greater than -1/2. So the domain for this one is greater than -1/2. So I've got this, and I've got this. That's the new piece you got to worry about. Now let's tackle this equation. Because a lot of you went, oh, I can get rid of the logs, and I'm good. I'll just solve this, and I'm all happy. Okay? So let's go ahead and deal with this. So we got x plus, oops. I don't know where you guys are at on solving equations. I just like to move everything quickly. This is going to move over here, so I get x minus 2x. This is going to move over here, so I get 1 minus 3. I get negative x is greater than -2. I am going to divide by a negative. This is a key rule right here. If I divide by a negative and I divide by a negative or multiply by a negative to clear this negative out, things switch. Allergies are kicking in. I get x is less than 2 is my answer. Okay, now. Okay, so I got less than 2. But we know we can't go below 0 by the definition of a logarithm. So let's look at these. I got 2 purple ones. Let's put them on a number line. So I'm going to put them on a number line. Got to put a 0 right there. Okay, I'm going to put them on a number line. And then from there, I'm going to say, okay, this answer says x can't be, has to be less than 2, right? Okay. And then these answers here say, well, where do my zeros happen? Well, we go to 3, 1, 2, 3. When I put negative 3 here, it says that it has to be greater than 3. And then I go to negative 1/2, which is right here. And I say at negative 1/2, it's got to be greater than that. So all 3 of these together give me an answer, because I know that it's got to have all 3 of these in the answer. So what point is this? This is negative 1/2. What point is this? This is 2. And we add our x in the middle, and that's my answer. So my answer has to be x such that negative 1/2 less than x less than 2 is my answer. How did I get this? I used all 3 of these inequalities right there. All 3 of them. Those are the harder ones. I get that. I don't want to make these videos too long. We're at 12 minutes right now. So hopefully this worked a lot better for you guys, and you guys can kind of see where we went with this. And I will get another video up for you guys soon. One of the things I wanted to talk to you guys about real quick, and you guys are in Math 2 Advanced. So let's just say Math 2 Advanced. And then some of you are going to AP Stats. AP, I won't do that big of a one here. AP Stats. And then you guys are going to go to AP Calculus. That's what some of you guys have decided that your track is. Okay? I just want to ask you a question. Just a real quick question. When you're in Math 2 Advanced, let's say you did Unit 1. When you get to Unit 4, do you remember everything from Unit 1? Okay? Most of you will say, no, I don't remember Unit 1 when I'm in Unit 4. Here's the problem. So everything in here is related to calculus. Everything in here is related to calculus. So you are telling me you are going to skip for at least 400 days. You're not going to have anything to do with calculus and come back and be successful in AP Calculus. Most of you will not be. So if you are doing this one here, I tell you, I would switch those two. Don't be fooled. AP Stats is no easier than AP Calculus. They're AP classes, guys. There's no easy AP class. If you're in AP Bio right now, that is the easiest AP class on this campus. Okay? So just know that you don't do this path, you will set yourself up for really big trouble in AP Calculus. So that's my advice to you guys. Let me know if you have any questions.